Now we can solve for the acceleration of block 1. Well, the acceleration is going to be caused by however much bigger this force is than this force, or Ft minus m1g. And that's going to equal m1 times a1. Now the problem is we can't just go and solve this for a1. Not yet anyways. This equation has two unknowns, a1 and the tension. One equation will never be able to solve for two unknowns. Maybe we can get more information by analyzing the second block. Well, let's do the diagram. And before we go any further, I'm going to move this equation over here to emphasize that it belongs with block 1. Now previously we showed that Ft has to be bigger than m1g since it's accelerating that way. Well, m2 we know must be accelerating this way. So m2g must be bigger than Ft. Now I've glossed over an important point here. Is this Ft here the same as this Ft here? And the answer is yes, it is. A rope always maintains the same tension throughout. Maybe you can prove it to yourself by trying to think about what would happen if somehow the rope's tension changed. What would happen at the boundary point where the tension changed? That's something you should talk about in the forums. Well, now the force doing the acceleration is however much bigger m2g is over Ft. And we can write a very similar equation. m2g minus Ft is equal to the mass times the acceleration. Net force equals mass times acceleration. And once again, we have two unknowns, a2 and Ft. Well, that gives us a total of three unknowns, Ft, a1, and a2. Two equations can never solve three unknowns. But hey, I realized something. These blocks are connected by a string. Any motion downwards from this guy has to correspond to motion upwards from this guy. That means this acceleration has to be identical to this one. We've done something a little strange here where we've called acceleration on this side positive when it's up, and on this side positive when it's down, but that's okay, we can do that. So now instead of writing a1 and a2, I can just write a. We're almost there. We're almost at something very cool. Because now we only have two unknowns, and two equations can solve two unknowns.